Hello, everyone. Welcome to Python Challenge for All. Okay, so where were we last time? Let's see. So we were trying to solve equation x squared minus 5 equals 0, which is to find the value of square root of 5. Okay? Right, using bisection method. So the idea is, first, we try to visualize the graph. And let's see where we were last. The code. So we were using Google Collaboratory. So please open it and connect it uh, to visualize the graph of x squared minus 5. We can use the graph like this. So as you know, um, we can easily draw a graph as this. Okay, let's run it again to make sure that we want to find the x value at this intersection. Okay, here, 2 point something, right? So to do that, the bisection method first tries to um, yeah, define the tolerance of kind of 10 to minus 5, the power of minus 5, negative 5, and then we repeat the process of finding the middle value, evaluating the f of m for f of x for the middle value, and if it is above x-axis, then change it like this way, or otherwise change it like this way. So use the middle value x as the high if it is above the x-axis. Otherwise, use the low value, x as the next low value. And repeating this, we can eventually find the square root of 5 as 2.236 and something with the tolerance of this value, okay, this value, okay, when it is below the tolerance, predefined tolerance, we can find the square root of 5 to a very good precision. Okay, that's the code. Please see that each time the interval is halved and eventually it is found. So today we're going to use another method called the Newton-Raphson method to find the value. Okay. So I don't know how much you're familiar with this idea, but the basic idea, okay, we can use Newton-Raphson method or Newton's method to find square root of 5. So the idea is set an initial guess as x equaled 5, and also so this time the iteration is like this: x prime equals x minus f of x over f prime of x. Okay, so the base idea is this. Here we make a tangent line, and then here again we make a tangent line, and repeating this we can find the root very very fast. That's the base idea of, okay, here, and then we make a tangent line. Okay, here again we make a tangent line. In this way we can find it by, yeah, the root automatically converges to what we want to find. So in this case, the prime, f prime is, yeah, we can we can differentiate this to x, right? So the problem that iteration is like this: x minus f over f of x over 2x. So let's do that. Okay, repeat till the tolerance is met. Okay, so let's run it and to see how well it works. Okay, so in this case we can make a text here to name it as Newton method. Newton-Raphson method. Okay, and then the code is very close to what we were doing last time. So initial x is 5, for example. And then for I in range, say we do it 100 times at most. And y equals f of x. Okay, we have already defined f of x as here. Here. So x squared minus 5. So it's okay to use it. And then we calculate, well, just for future use, print I, x, and y. Okay, good. And then if absolute value of y is smaller than delta, we can just break from the loop. Otherwise, we make the next definition of x, which is, as I said, f of x. Yeah, f of x over 2 times x. Actually, what I want to show is x minus. So maybe we can write this way, x minus y over 2x. Or, as you know, in Python, we can write this way, minus equal y over 2x. And this is all. And this is very simple, right? So let's see how fast it can find the answer. Okay, let's run it. Okay, only in 5 repetitions, 5 iterations, we reach the good value of this one. Okay, let's see if it is correct. If we square this, okay, if we square this, we can check that it is very close to 5.0. Very good. So this is how the Newton-Raphson method works. And actually, it's much faster. In the previous bisection method, it took 20 rounds, 20 iterations to reach this value. But in Newton-Raphson method, it took only 5 rounds. So it converges much, much faster than the previous method, my bisection method. Okay, that's how the algorithm works. So I've explained it, and you run it. You can check with your function as well. So that's all for today. Maybe next time we'll compare the speed visually by drawing a graph. Okay, so be sure to come back. Bye bye.